Continuing our discussion of 1.3, you're going to see that to solve quadratic equations in this complex number system, we have to first decide what the roots of the negative numbers are equal to. By definition, the square root of -1 we decided was I. So by definition, the square root of -1 is I. If we want to split that up into smaller fragments, we could say the square root of -9 is the square root of -1 times the square root of 9. We know that square root of -1 is I, and the square root of 9 is 3. So by definition, the square root of -9 is actually a non-real number. It's impossible to find a real answer that multiplies by itself to get -9. However, we do have an imaginary number. And we could check this. 3i times 3i should give me -9. Well, let's see. 3 times 3 is 9. I times I is I squared. And by definition from the previous page, I squared is -1, which is -9. So you can see that that does check out with what's underneath the square root symbol. Let's try another. Square root of -18 is the square root of -1 times the square root of 9 times the square root of 2. The reason I broke it down into those numbers is because the first thing I want to do is pull out the negative. Then I look at 18 and decide, are there any perfect squares that are factors of 18? 9 is a perfect square that is a factor, so I pull it out. 2 is the remainder. So I have square root of -1, which is I, square root of 9, which is 3, just like we did up here, but then I still have this remainder of square root of 2 left over. So this is how we're going to simplify roots that have negative numbers underneath. Now let's work on a couple of examples of solving quadratics. You'll see here in the complex number system, as I stated at the beginning of the lecture, that we always want to look at the discriminant. If the discriminant is positive, we have two real solutions. If the discriminant is 0, there's one real solution. And if the discriminant is negative, then there are two complex imaginary solutions. Okay? So we're going to use the quadratic formula to solve this equation. It's not factorable, so we're going to have to use quadratic formula. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So this becomes 6 plus or minus square root of 36 minus 52 all over 2, which is equal to 6 plus or minus the square root of -16 over 2. So now we have to determine how to simplify this. Since the discriminant, this is the discriminant. b squared minus 4ac is the discriminant, and the discriminant is negative. Since the discriminant is negative, there will be two complex solutions, or two imaginary solutions. So simplifying this, we have square root of -1 times square root of 16, which can be simplified. Square root of -1 is I, square root of 16 is 4, and this can be reduced. When I pull a 2 out of the top, I'm left with 3 plus 2i inside, and you'll see that those 2's will cancel. So I'm left with 3 plus or minus 2i. So my answers x are going to equal, I'm going to have two solutions. One at 3 plus 2i, and the other at 3 minus 2i. Two complex solutions, and they will be conjugates of each other. These two answers are conjugates of each other. Let's do one more. Let's ask to find the solutions here. Let's use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Simplifying, we have 2 plus or minus the square root of 4 minus 20 times 4, which is 80, over 10. 2 plus or minus the square root of negative 76 over 10. So since the discriminant is negative, that means we'll have two complex solutions. So we're going to have to solve for those two complex answers. So let's simplify. 76 can be broken down into two numbers that multiply together to make 76. I do know 4 divides into 76 19 times. So I pull the 4 out because I know it's a perfect square. Square root of negative 1 is I. Square root of 4 is 2. And then my square root of 19 is my remainder. So now let's simplify. Both 2's are even, so I can pull a 2 as a greatest common factor out of the numerator. When I pull a 2 out of the numerator, it's going to leave me with 1 plus or minus 1i square root of 19 over 10. And these will reduce to 1 over 5. So I'll have 1 plus or minus I square root of 19 over 5 as my two answers. But remember, when I said we write these, we generally want to write these as two separate fractions. Write it as the real and the imaginary parts separately. So I would say my two answers are 1/5 plus square root of 19 over 5, I, and my other answer will be 1/5 minus square root of 19 over 5, I. So those are my two answers.